Given, you are given an integer array nums. Mirror pair, indices I and j with 0 at most I less than j, j less than n, and reverse of nums at I equals nums at j. Reverse means flip the decimal digits and drop leading zeros. Example reverse of 120 is 21. Return, the smallest absolute gap between indices among all mirror pairs, or -1 if there are none. Constraints, length between 2 and 10 to the 5th, each value between 1 and 10 to the 9th. In this example, highlight indices 0 and 1. Reverse 12 is 21, which equals nums at index 1. So j minus I is 1 minus 0 equals 1. A later mirror pair has a larger gap, so the minimum is 1. Second example, 21 then 120. Reverse 21 is 12, but no later nums entry is 12. Reverse 120 is 21 with no valid j after index 0. No mirror pair, so output is -1. 12 and 21 are mirrors. Reverse the digits of 12 and you get 21. 120 becomes 021 after reversing digits, then the leading 0 drops, leaving 21. Brute force fixes I on 12 and scans every j ahead, hoping reverse of nums, I, appears as nums, j. That nested pattern explodes, on the order of n squared checks, far too heavy when n reaches 100,000. Instead of rescanning from every I, walk once and keep a dictionary of what you have already seen. At the current index you look up nums, I, itself among keys built from earlier reverse values. Store reverse of each value with its index. At index 3 the entry 21 is already a key from index 0, so you read off the gap 3 minus 0 equals 3. That hit is the dictionary telling you where an earlier mirror lived. Keep the smallest abs distance seen whenever a map hit happens. Later pairs can tighten that bound down to 1 in the full array. Overall it is one linear scan with a hash map for linear extra memory. We solve it with one left-to-right scan. The map stores reverse of nums at j as the key and j as the value, but we only keep the latest index for each key. Before writing a new entry, look up nums, j. If that key exists, the stored index is the closest valid left partner, so relax the running minimum with j minus that index. The best gap box starts at infinity. Iteration j equals 0. Nums at 0 is 12. Look up 12 as a key, the map is empty, so there is no earlier mirror to pair with. Insert reverse of 12, which is 21, mapped to index 0. The best gap stays infinite because we have not seen a pair yet. Iteration j equals 1. Nums at 1 is 21. Look up 21, the map already has 21 pointing at index 0, so we have a mirror pair from 0 to 1. The gap is 1 minus 0 equals 1, and the best gap becomes 1. Then insert reverse of 21, which is 12, mapped to index 1. Iteration j equals 2. Nums at 2 is 45. Look up 45, it is not a key yet, so no new pair. Insert reverse of 45, which is 54, mapped to index 2. The best gap stays 1. Iteration j equals 3. Nums at 3 is 33. Look up 33, not present, so no hit. Reverse of 33 is still 33, so insert 33 mapped to index 3. The best gap remains 1. Iteration j equals 4. Nums at 4 is 54. Look up 54, the map has 54 at index 2, so we get a pair from 2 to 4 with gap 4 minus 2 equals 2. The running minimum stays 1 because 2 is worse. Then insert reverse of 54, which is 45, mapped to index 4. After the last index, the value in the best gap box is the answer. Here it is 1. If no lookup ever improved it from infinity, you would return -1. Complexity. Let n be the length of nums. Time is O of n, 1 pass over j, constant map work per step. We only keep the latest index per reverse key, so no inner loop is needed. Space is O of n for the map keys in the worst case. Function min mirror distance on nums. Initialize by as an empty map from reverse value to the latest index. Set best to none. Loop j from 0 to length of nums minus 1. If nums at j is already a key in by, some earlier index had that reverse ghost. Distance is j minus the stored index for that key. If best is still none, or d is smaller than best, then assign best to d. Let r be reverse decimal digits of nums at j. Store or overwrite by at r with j, keeping only the latest index. After the scan, if best is still none, return -1, no mirror pair existed. Otherwise return best, the minimum gap found.